Gravitational microlensing is an astronomical phenomenon due to the gravitational lens effect. It can be used to detect objects that range from the mass of a planet to the mass of a star, regardless of the light they emit. Typically, astronomers can only detect bright objects that emit much light, stars, or large objects that block background light, clouds of gas and dust. These objects make up only a minor portion of the mass of a galaxy. Microlensing allows the study of objects that emit little or no light. Gravitational microlensing was first theorized by Refstal, 1964, and first discovered by Irwin et al., 1988. The first object in the sky where it was discovered was the Einstein Cross or Hooker lens 2237+0305. The initial light curve of the object was published by Corrigan et al., 1991. In Corrigan et al., 1991, they calculated that the object causing the microlensing was a Jupiter-sized object. This was the first discovery of a planet in another galaxy. When a distant star or quasar gets sufficiently aligned with a massive compact foreground object, the bending of light due to its gravitational field, as discussed by Albert Einstein in 1915, leads to two distorted images, generally unresolved, resulting in an observable magnification. The time scale of the transient brightening depends on the mass of the foreground object as well as on the relative proportion between the background source and the foreground lens object. Ideally aligned, microlensing produces a clear buffer between the radiation from the lens and source objects. It magnifies the distant source, revealing it or enhancing its size and or brightness. It enables the study of the population of faint or dark objects such as brown dwarfs, red dwarfs, planets, white dwarfs, neutron stars, black holes, and massive compact halo objects. Such lensing works at all wavelengths, magnifying and producing a wide range of possible warping for distant source objects that emit any kind of electromagnetic radiation. Microlensing by an isolated object was first detected in 1989. Since then, microlensing has been used to constrain the nature of the dark matter, detect exoplanets, study limb darkening in distant stars, constrain the binary star population, and constrain the structure of the Milky Way's disk. Microlensing has also been proposed as a means to find dark objects like brown dwarfs and black holes, study star spots, measure stellar rotation, and probe quasars including their accretion disks. Microlensing was used in 2018 to detect Icarus, then the most distant star ever observed.